Good morning, dear students. Today we are going to discuss one more important topic, that is hypothesis testing. How hypothesis test works. Before this we have studied about concept of hypothesis, meaning and definition of hypothesis. Then in my previous video, terminologies of hypothesis part 1 and terminologies part 2. Now this is my fourth video on hypothesis testing. How hypothesis test works, we will study in detail. What are the number of points we are going to discuss in this particular video? This is mentioned it here. First, decide population mean as null hypothesis. Then sampling distribution. Then another is graphing our sampling mean in the context of sampling distribution. Then graphing significance label as critical regions using p-values and significance label together. Now in detail we are going to study about how hypothesis test works. For that, this particular concept, I have taken one example, and with this example we will more clear about this concept. What is this example? This example is a researcher is studying fuel expenditure for the families and wants to determine if the monthly cost had changed since last year, when the average was $260 per month. The researcher draw a random sample of 25 families and analyzed their monthly cost for this year. Now, the researcher collected a random sample and found that this year's sample mean 330.6 is greater than the last year's mean 260. By performing a hypothesis test at all, we can see that this year this mean is higher by $70. But this situation isn't as straightforward as we think, because we are analyzing a sample instead of full population. There are huge benefits when working with the samples, because it is usually impossible to collect the data from entire population. For this is the example. With this example we will understand detail about this concept. Now, it is improbable for any sample mean to equal the population mean because of the sample error. In this case, sampling mean of 330.6 is almost definitely not equal to the population mean for the fuel expenditure. If we could obtain a substantial number of random sample and calculate the sampling mean for each sample, we do observe a broad spectrum of the sample's mean. We do even able to graph the distribution of the sampling means from this process. This type of the distribution is called sampling distribution. We can obtain sampling distribution by drawing many random samples of the sample size from the same population. The sampling distribution allows to determine the likelihood of obtaining sample statistics. They are crucial for the performing hypothesis test. So what we will do, we will calculate, from the same size of the population, we will make some more studies, some more samples, and that means will also be collected, and this will be called as the sampling distribution. And by this help of this sampling distribution, we can make our hypothesis test. In next slide, we want to find out if the average fuel expenditure this year 330.6 is different from the last year 260. The answer this question we will graph the sampling distribution based on the assumption that the mean fuel cost for the entire population has not changed and is still 260. Hypothesis tests always use sampling distribution that assume the null hypothesis correct. Null hypothesis is correct. Likewise, we use the null hypothesis value as the basis of comparison for our observed sampling values. So then, if you have number of samples, and like here 260 is our population mean, and whatever number of other samples we have collected, we will find out and compare with this which one is nearby and which one is far away from this population mean. Will study these things. Now next, the graphing our sampling mean is context of the sampling distribution. The graphs for below shows that each sample mean are more likely and less likely each population mean is 260. We can place our sample mean in this distribution. This broader context help us see how unlikely our sample mean is if the null hypothesis is correct. Mu is equal to 260. What we will do, we will draw a number of samples and then other means, and then we'll find out which one is nearby and which one is not, more likely and less likely. Find out these things by this particular graph. Now next, the graph displays the estimated distribution of sample means. The most likely values are near to 60 because the plot assumes that this is the real population mean. However, given random sampling error, it would not be surprising to observe sample means ranging from 167 to 352 if the population mean is still 260, or observed sample means 360.6 isn't the most likely value, but it's not entirely impossible either. So here what we will see, here we have population mean, and we'll find out which one is nearby and which one is far away. For that we have make our one range ranging from 167 to 352. This is 167 and this is 352. We'll range it and we'll see how much our sample means are falling in this particular region. Now on the probability plot, the entire area under the distribution curve equal 1, the population of the area under a curve corresponds to a range of the values along the x-axis represents the likelihood a value will fall within that range. So all this particular region is equal to 1, and here we will see how the population of the area under the curve corresponds to a range of the values along with the x-axis represent the likelihood a value will be fall within this range. Then hypothesis test use ability of probability distribution to calculate probabilities for the range of values to determine statistical significance. Main purpose of this is because we are able to calculate this. We are able to hypothesis can ability to probability distribution calculate. We can calculate only this particular regions where we are our mean from 167 to, so we will find out what are the number of probabilities, because infinite level we are not able to find study. Suppose here one sample mean is falling at here, then here, then it will be infinite. Then we will decide up to which particular range we should calculate the probabilities for the range of the values to determine statistical significance. Statistical significance will decide at here. Now, in next slide, the sampling distribution indicates that we are relatively unlikely to obtain a sample of 330.6. If the population mean is 260, is our sample means so unlikely that we can reject the notion that the population mean is 260. Now, in the statistics, we call this rejecting the null hypothesis. If we reject the null for our examples, the difference between the sample means 330.6 and 260 is statistically significant. In other words, the simple data favor the hypothesis that population average does not equal to 60. So what we will do, the sampling distribution indicate that we are relatively unlikely to obtain a sample of 330.6. If the population mean is 260, is our sample mean so unlikely that we can reject it? So here we will find out that our calculated or observed population mean, observed mean is this 330.6. Each will be compared with the 360, and we will find out it is this is our sample mean so unlikely that we can reject it. In statistics, we call this rejecting the null hypothesis. If we reject the null for our sample, the difference between the sample means 330.6 and 260 is statistically significant. In other words, the sample data favor the hypothesis that population average does not equal to 260. Now, however, look at the sampling distribution chart. Again, notice that there is no particular location on the curve where you can definitely draw this conclusion. There is only a consistent decreases in the likelihood of observing samples, means that are further from the null hypothesis value. Where do we decide the sample mean is far away enough? So in this particular graph, we can see there is no any region from a particular location from where we can reject to any particular sample. We don't have any particular area from where critical area. So we will decide next point. We'll decide critical area by which we can reject. If our sample is falling in that particular area, then we can reject. If that will in the midpoint of the null hypothesis, then it will accept. Now in next slide. To answer this question, we will need more hypothesis testing tool. The hypothesis testing procedure qualifies our samples unusualness with the probability and then compares it to an evidentiary standard. This process allows you to make an objective decisions about the strength of the evidence. Okay. So we have required more hypothesis tools, testing procedures. we are going to add the tools we need to make this decision to graph significance label and p-values. These tools allows us to test these two hypotheses. Null hypothesis, the population mean equals the null hypothesis means 260. Then alternative hypothesis, the population mean does not equal the null hypothesis means 260. Okay, for that purpose we will use some hypothesis tools also. Now, in next slide. The graphing significance label as critical region. A significance label, also known as the alpha, is an evidentiary standard that a researcher sets before the study. If it defines how strong the sample evidence must contradict the null hypothesis before you can reject the null hypothesis for the entire population, the strength of the evidence is determined by the probability of rejecting a true null hypothesis. Lower significance label requires strong sample evidence to be able to reject the null hypothesis. For example, to be statistically significant at 0.01 significance label require more substantial evidence than the 0.05 significance label. On the probability distribution plot, the significance label defines how far the sample values must be from the null values before we can reject the null hypothesis. The percentage of the area under the curve that is shaded equal the probability that the sample value will fall in those regions if the null hypothesis is correct. So then, if null hypothesis is correct, we will decide here the region, and then this region is called as a critical region, and this is the rejection region, and this is the acceptance region. Null hypothesis acceptance region. By this way, we will decide the critical region of the graphing significance label, and as critical region. This is the this process will do it, this particular process by tools. To represent a significance label of 0.05, we will set 5% of distribution furthest from the null values. This one will decide two critical region, two-tailed critical region for the significance label of 0.05 here. This one, and this is the 260 in the population mean, and this is the observed sample mean, which is 330.6 is falling in this particular critical region. Explanation about this we'll discuss in this slide. The critical region defines the sample values that are improbable enough to warrant rejecting the null hypothesis. If the null hypothesis is correct and population mean is 260, random sample N25 from this population have means that fall in the critical regions 5% of the time. What are the p-values? The p-values are the probability that a sample will have an effect, at least extreme edge effect observed in your samples if the null hypothesis is correct. Okay. first we need to calculate the effect that is present in our sample. The effect is distance between the sample values and the null values. 330.6 minus 260 equal to 70.6. Next we'll shaded the region on the both the sides of the distribution that are at least as far away as 70.6 from the null. 260 plus minus to 70.6. This process graph the probability of observing a sample means at least as extreme as our sample means. So this is the way by which we can decide values, null values. 330.6, then this is the plus minus. If this particular sample is critically, we'll analyze the critical region or in null region. Now in next slide we'll discuss about what is the total probability of the two shaded regions is 0.03112. The null hypothesis value 260 is the true. It drew many random samples. You do accept sample and you means to fall in the shaded regions about 3.1% of the time. In other words, you will observe the sample effects at least as large as 70.6 about 3.1% of the time. If the null hypothesis is correct, that's the p-value. Now using p-values and significance label together. If your p-value is less than or equal to your alpha label, reject the null hypothesis. The p-values results are consistent with our graphical representation. The p-value of 0.03112 is significant at the alpha label of 0.05 with the significance label of 0.05. The sample effect is statistically significant. Now, our data supports the alternative hypothesis which states that the population means does not equal to 260. We can conclude that the means fuel expenditure had increased since the last year. Discussion about the statistical significance results. The hypothesis tests determine that whether your sample data provide evidence that is strong enough to rejecting the null hypothesis. For this entire population, the test compares your sample statistics to null hypothesis, null value, and determine whether it is sufficiently rare. Sufficiently rare is defined in a hypothesis test by assuming that the null hypothesis is correct. The graph center of the null value. Then next, the significance alpha label, how far from the null value is the critical region. And last one, the sample statistics is within the critical region. These things we will consider in hypothesis testing process. In the last slide, we will see the recap. In recap, we will study about how hypothesis test works. These all 4 points we have studied in my first slide. All 4 points we will see one by one in this particular slide. Decide population mean as or null hypothesis and sampling distribution. Population mean, it was the 260 we have seen in example. 260 was the expenditure of the fuel last year of the family's consumption. And here it will be our population mean and hypothesis also. Now, how you will decide the sampling distribution? Sampling distribution. What is sampling distribution? If same size of the population will take the samples and will make the calculation the means, then on the basis of that means we'll make the graph, and graphical presentation is called as the sampling distribution. After sampling distribution, what we will do? We have decided range also for the up to which particular range we will make our study. Like here 167, we have decided 167 and 352. 167 and 352 was the range in this particular study. Researcher have made their study in present year, and he has got their sample mean was 330.6, and this 330.6 was falling in particular region, this particular region. But when we have studied in previous slide, we were not able to decide where we will accept this mean or we will reject this mean. For that purpose, it is important to do what we will do, the graphing significance label as critical region. So graphing here, we will graphing the significance label. Suppose this particular area 330.6 get the p-value at 5% label, it will be 0.03112, and this will fall in this particular area. So then we will go for in this particular 5% label of significance, we will know about what will be the critical region. So using p-value and significance label together, at 5% label of significance, we will decide the critical area, and we can see the researchers calculated observed mean is falling in this particular region, and this particular region is in critical area. So this particular mean value will be rejected. If this value will be in this particular region, then it will be accepted. Null hypothesis will accept it. Here null hypothesis will reject. This is all about this study. How hypothesis test works in detail we have discussed. Now in next slide we'll discuss more about the hypothesis testing. What are the number of tests and what are the number of procedure of using test. Thank you very much.